Hey everyone, welcome back. So in the last video, we have learned about the multi-container pod. But Kubernetes has another type of container that run in very different way. It is called an init containers. So in this video, we will cover what is init container, why do we need init containers, and we will also see some of the real-time example for the init containers. And at last, we will write the YAML file and we will do the hands on it. So let's get started. Now imagine you have an application that need a database to be ready before it starts. Or maybe your application need to download some file before it runs. And in this case, if you just start your main application directly, it will crash or fail because the dependency is not ready yet. So this is exactly the problem init container solve. So what is init container? Init container is a special type of container that run before the main application start. Think of like an initial step. The init container run first, complete the task, exit successfully, and then after Kubernetes start the main application. If the init container fail, the main container never start. Kubernetes keep trying the init container until it succeed. So let me give you a simple example. Think of like a restaurant kitchen. So before chef start cooking, the kitchen must be clean, ingredient must be prepared, and oven must be preheated. The chef does not start cooking until all preparation is done. So in Kubernetes, kitchen preparation is equal to init container, chef cooking is equal to main application container, and the restaurant is equal to pod. So here are some of the common real examples for the init container. So first, download file before the application start. The init container download the zip file and save it to the shared volume. The main container read those file and start it. Second, wait for the database to be ready. So your application needs a database. The init container keep checking until database is available. If available, then it exit and the main application start only if the database is ready. Third, run the database migration. So init container run the database migration script before the application start. Fourth, set permission or ownership. The init container set the correct file permissions on the shared volume before the main application use it. So before we write a YAML file, I wanted to quickly introduce a new concept, a volume. So in our example, the init container will download the file and main container need to read those files. But the container are isolated, so they cannot access each other files. So Kubernetes give us a volume. Think of like a shared folder where both container can access. The init container write the files in the shared folder and the main container read from the shared folder. So we will cover the volume in detail in the separate video. But for now, just remember volume is equal to share folder between the container inside a pod. Now let's understand the YAML file that we are going to create. So in this example, we have a two container using a BGBox image inside the same pod. The init container which download the zip file and extract into the shared volume and then exit. After the init container finish, main container start and use the file from the shared volume. Now let's run the YAML file on the real Kubernetes cluster. So for that, open the killercoder.com, then select a Kubernetes playground and wait for the environment to load. Now let's verify the cluster. And you should see your control plane and worker node are in ready state. So let's get started. So now let's create the YAML file using a vi commands. So vi and the file name. Now press I to enter into the insert mode and copy the YAML file. Then press escape and then type :wq and press enter to save. Let's verify the YAML file which we have created. So we will use cat command for this, and this file looks correct. Now let's create the pod. So the pod has been created and you will see the pod init container demo created. Now let's get the status of the pod and you will see something like this. Look at the status column carefully. It says init 0/1. This means 0 init container is completed out of total 1, and the init container is still running and it is downloading and zipping the files. The main container is not started yet, and this is the init container in action. Kubernetes is waiting to init container to finish to start the main container. Now let's see what init container is doing in the real time. We will use kubectl -f, pod name and -c container name. And you will see output like this. The init container has downloaded the zip file and then unzip into the /data folder. Now let's check the port status again, and you will see the init container has completed successfully and the main container is running now. Now let's go inside the main container and check if the downloaded file is available. Now we are inside the main container. Let's check the shared volume. The main container can access the file downloaded by the init container because they shared the same volume. Now let's exit from the container. Now let's describe the pod, and to describe the pod we will use kubectl describe pod and pod name. Scroll to the init container section, and you will see the state is equal to terminated, region is equal to completed, and exit is equal to 0. Exit 0 means the init container finished successfully. Scroll to the container section and you will see app container listed with state is equal to running. This confirms the sequence. The init container run first, completed successfully, and then main container has started. Now we can delete the pod, and to delete the pod we can use kubectl delete -f and the file name. It will delete the pod. The pod has been deleted. Now let's check the status again, and you see no resource found in the default namespace. So let's quickly recap. Init container runs before the main container start. The main container only start after all init container completed successfully. If init container fail, the main container never start. Kubernetes retry it automatically. If we have a multiple init container, they run one by one in order. Init container and main container can share the data using the shared volume. The status column init 0 by 1 means init container is still running. So that's everything about the init container. In the next video, we'll learn about the ephemeral container. Thanks for watching, and I'll see you next video.